Hello everyone, in this project we will explore the optimal unit commitment of a hybrid microgrid. And the solver which is used in this project is mixed integer linear programming. So let's go through the concept and all through the tables and figures. So imagine we have a small island or a remote factory where we have a small power grid, and our grid is not connected to the main utility. So we may get three types of powers. Like we get solar panels, which is a form of free energy which is available during the day. We can utilize the diesel generator, reliable, but fuel is expensive, and we will utilize it at the peak times. And next we have the battery storage, which we will consider this for the charging and discharging. So the challenge here is to how we can schedule all our resources for 24 hours for the minimum cost. So when to turn on the diesel generators and when to charge and discharge the batteries. So that's the complex setup which we have to solve in this project, and we are utilizing the mixed integer linear programming. We may use another PSO genetic algorithm and any type of other optimization algorithm. But for case simplicity in this project, this is utilized, and this is the MATLAB built-in function. So let's start with the optimal power dispatch chart. So here on the x-axis we have 24 hours, and from this table you can see that the red bars which represent the load demand during the day, and these are the peak hours, or during the day we have more load demand as compared to the in the early morning and in the evening. So the gray bars which represent the diesel generator, initially in the start of the morning we have not available our solar, so that's why we have to utilize the diesel generator, and similarly in the evening we have to utilize our diesel generator. These yellow bars in the middle of the day, which are on peak, on highest level, this represent that we have our solar power which goes up as we move into the afternoon, and then when we move from noon to evening, the bars shows down. And here are we have green bars here. So these bars represent the battery charge. So at these hours we have excess solar generation. We may charge our batteries using that excess power, and later on using this battery discharge, here you can see in the evening we utilize that power in form of batteries which we stored using the solar power, and that are utilized here. So that's how everything works together. And here in the below figure, here you can see that this is the red dotted line, which is the minimum SOC, minimum level for our batteries, and at this point we have maximum SOC of 90%. So at this hour, from this to this, from these hours, we have our batteries. From this hour to this hour, we have to turn on our diesel generator to give power to our load, and at these hours we have to again turn on our diesel generator. So status will be 1, which is on, and at these hours we have turned off the MATLAB code. Find these hours where we can turn off our diesel generator, and we may utilize the solar power which will run our load, as well as these hour it will charge our battery energy storage system. And from these hours it again discharge our batteries, so we may serve our load. So here in this hour, so this is the curve where we can see the battery SOC, charging, discharging, and the diesel status turn on and off. And let's see here in the tables. So in this, I just mention how much capacity we are utilizing and taking. And here, this table is very important. Here in the start of the second hour, our load is 51.58, but our batteries are not charged. Our SOC is around 50%, and all our load is served by the diesel generator, and the cost we are facing here is 25.63. I will talk later about how much cost we are paying for each kilowatt in form of the diesel generator. And here, if I consider at the 12 hour, we have 66.66 kilowatt load, and diesel generator is turned off right over here. No gray line is there. And here is minus 53. So this minus 53 is represent this green bars where we are charging our batteries, and that's why this represent as the minus kilowatt. And our battery SOC is 47.3, and all our power is taken from the solar. So we are serving 66 kilowatt in form of load, and other this type these kilowatts to charge our batteries, because our solar are not full efficient and we may add few noise over there. So that's why this number a little low, and the cost we are getting here is 2.67. So after all this sum up, we have the final cost, operation cost, which is $498.61 throughout the day. And if we utilize all our power using the diesel generator, we may face a lot of cost if we run the diesel generator throughout the day. So that's how this is optimal unit commitment work for hybrid microgrid, and it's very cost efficient, which you can see $498 for a day of 24 hours. And now let me explain the MATLAB script file. So this is the MATLAB script file. Here in the start of the time period for 24 hours is mentioned, and then base load plus morning peak plus evening peak. So we have base load, we have a peak in the morning, and we have a peak of load in the evening. So that's how this curve is created, and some noise is added there. And for solar profile, we may take data for a specific location, or right now I just consider Gaussian centered at noon. So we have a solar peak in the noon, in the middle, and in the night we have a zero. So that's how the solar profile is created, which you can see. This is like a Gaussian peak. And next, there are a few parameters for the diesel generator parameters. Maximum capacity mentioned there, minimum kilowatts when it will be turned on, and the cost mentioned over here. Based on this cost, we have evaluate this table and the price for that. And later on, we have some other parameters for battery charge, discharge, and all that stuff. So let me open this build MILP matrices, which is about the mostly about all the parameters, how we set up the parameters. So in this file, we have mainly deal with the 5 variables. So first one, this is the P generation, which is the diesel generator power, which we have to inject. And then the next one, which is the generator status, it's turned on or off. And the next is the charge, which is the represent the battery charge, and next is the battery discharge, and the final one is the battery energy. So how much capacity of or how much power we have in our batteries. So these are the 5 variables which we have to deal with it. And next, just the indexes for easy access. And here is again representation, or just arranging all that stuff to prepare our F variable. I mean, inside a single variable we are considering all our variables, all our data, which we have to then import into our main program. Here you can see the f. So after this, then we have a call for other stuff, and here are our equality constraints. So these equality constraints, what exactly are they? They are ensuring the supply equals demand for each hour, and here you can see our generation in form of diesel plus our battery discharge, and if we are charging the batteries, we are subtracting that, and then equals to our load minus P solar, how much we are taking from the solar. So that power will be deducted from the load. So that's how all the logic work over here. And next here are our battery dynamics, which actually links the energy at time to the next interval of previous time interval t-1. So in our inequality constraints, we have to link our variables with the power variables, and next are some bounds for that mentioning. And here is the final file, which is the main microgrid EMS. Here just display the capacity and the diesel generation capacity and the solar profiles and other data. And here is the build up for the optimization for this prompt. So all the data is arranged over here. So all the data is arranged for this variable, which is built up here, and that is result pairing, and finally we have the visualization. So that's how all this stuff work together, and you may see that the MATLAB code works very well, and we get a cost effective, efficient solution. So that's how it works, and hopefully you get some idea and some insights about the project. If you like the video, please hit the like button, and thanks for watching.